Aim: to investigate how the increase in height of incline affects the motion of the ball as it goes down the ramp.
Hypothesis: the higher the incline of the pipe, the speed, velocity, acceleration, distance, and displacement increases.
This is our scientific diagram.
This was our risk assessment. These were the steps used to conduct the experiment. The results from the experiment supported this hypothesis. To ensure validity, we identified the independent variable as the height of the pipe, as we changed it from 0.1 meters to 0.2 meters to 0.3 meters. This was because the aim of the experiment was to investigate the effect of time, the dependent variable, as the height of the pipe increases. In addition, to ensure validity, we made sure our controlled variables, such as the weight of the golf ball, which was 46 grams, and the length of pipe of 1 meter, were consistent. It was important that we controlled these variables, as it would lead to too many independent variables and would be difficult to measure our results and come to a conclusion, hence affecting the reliability. We also had a control where the horizontal height, 0 meters, was used to identify the change.
The materials needed included a retort stand, a clamp, a boss head, a camera, a golf ball, a 1 meter ruler, and a 1 meter pipe.
These were the trials for 0.1 meter height. These were the 0.2 meter trials. These were the videos for the 0.3 meter trials. We calculated the speed/velocity for each trial and height by using the formula speed is equal to distance over time. We also calculated the acceleration for each height and for each trial by using the formula acceleration is equal to final velocity minus initial velocity over time.
To ensure reliability, repetition of the experiment was conducted. We repeated the experiment 3 times where we rolled the ball from 0.1 meters, 0.2 meters, 0.3 meters in height 3 times each. This would improve the reliability of the experiment, as repetition decreases the likelihood for the experiment to be invalid. It verified our results, providing supporting evidence for the hypothesis.
When analyzing our graphs, it can be seen that all 3 trials were reliable, as the results for time differed between a range of 0.23 seconds for the height of 0.1 meter. This can also be seen in the graph for 0.2 meter trials, as it showed a 0.49 second difference in range, and the 0.3 meter trial showed even further reliability, as the range was just 0.1 second. Smaller range suggests that the results were clustered together, meaning that the results were consistent. Furthermore, it shows that our experiment was valid, as minimal discrepancies were present during the experiment. It can be inferred from the graphs that as the height of the pipe increases, the time taken for the golf ball to roll down decreases. For example, for the 0.1 meter height, it took the golf ball an average of 1.45 seconds to roll down. For the height of 0.2 meter, a shorter time was taken, as it took 1.29 seconds on average, and the 0.3 meter height resulted in an even shorter time of 0.96 seconds. This relationship is also seen in the acceleration, as the 0.3 meter height's average acceleration was 1.09 meters per second square, which was larger than the acceleration of the 0.2 meter trials, which was 0.65 meters per second square, and 0.1 meter trials, which was 0.48 meters per second square. The acceleration for 0.1 meter height trials range was 0.14 seconds, which shows that each trial was reliable, as the results were extremely similar. However, for the 0.2 meter height, the trials differed by 0.44 seconds, which may be reflected in the outlier from trial 2 and suggests that some factors could have affected our results, such as inaccuracies in measuring height and time. For 0.3 meter height, the trials for acceleration differed by 0.23 seconds. The average speed and velocity of the 0.3 meter results was 1.04 meters per second, whereas for 0.2 meters it was 0.79 meters per second and 0.69 meters per second for the 0.1 meter height, which hence supports a hypothesis that as height increases, speed and velocity will also increase. 0.1 meter height trials had a range of 0.11 meters per second, 0.2 meters was 0.29 meters per second, and 0.11 meters per second for 0.3 meter height. Analyzing these results showed further inconsistency in the 0.2 meter trials as the speed and velocity as well as acceleration differed more than the 0.1 meter and 0.3 meter height. In addition, during trial 1, the speed and velocity for 0.2 meters was lower than the velocity of the 0.1 meter height, which hence has affected the acceleration and time as outliers. Therefore, it shows some inconsistencies in our method that may have caused this to occur. Throughout the experiment, it was hypothesized that the results would show decreasing time as height of incline increases. However, during trial 1, an outlier can be seen as the 0.2 meter height took 0.19 seconds longer than the 0.1 meter height. Consequently, the speed and velocity was slower than the 0.1 meter trial. This inconsistency may be as a result of human error, which will be explained later on. For trial 2 and 3, the results matched the hypothesis as 0.1 meter height resulted in longer time to reach the end of the half pipe than 0.2 and 0.3 meters.
We calculated the displacement by using the displacement formula. The 0.1, 0.2, and 0.3 meter graphs show that displacement increases as time increases, which can be seen in the increasing linear relationship on the graphs. For example, the displacement for 0.1 meter at 0.1 second was 0.0348 meters, for 0.2 meters at the same time was 0.0397 meters, and for 0.3 meters it was 0.0522 meters, which shows that the displacement of the 0.3 meter height at 0.1 second was further than the 0.2 and 0.1 meter displacement. This is because the increase in gravitational potential energy due to increasing height leads to greater kinetic energy converted when the ball goes down the ramp, so speed, velocity increases. The average displacement for each height increased steadily, however the graph for 0.2 meter displayed a larger deviation from the trend line compared to the 0.1 meter and 0.3 meter graphs. This can be derived from the 0.2 meters results for time, which are 1.58 seconds, 1.2 seconds, and 1.09 seconds. There is a larger difference in between the results. Indicates that at specific times the golf ball did not roll down at the same speed as the other trials, which led to the asymmetry of the displacement time graph. However, our displacement time graph's gradient showed that velocity was constant. In our speed and velocity time graph, it shows that speed increased as time increased. This error may be as a result of human error, such as timing our results and measuring the height of the ramp. The speed, velocity versus time graph for 0.1, 0.2, and 0.3 meter height shows a linear relationship after using the equation v is equal to u plus at. The trend line in red shows that the speed and velocity increased steadily as time increased, and that acceleration was constant as the ball went down the ramp. For the average velocity of 0.1 meter height at 1 second, the velocity was 0.48 meters per second, whereas for 0.2 meters it was 0.64 meters per second, and 0.3 meters was 0.98 meters per second. This is because a higher incline increases the acceleration of the ball, so the velocity also increases. The acceleration of the ball also increases as height increases. The horizontal line shows that acceleration was constant for each height, hence velocity increased and displacement also increased. Although the acceleration was constant for each height, it is evident that the 0.3 meter height's average acceleration was 1.09 meters per second square, which is higher than 0.2 and 0.1 meters, as they had 0.48 meters per second and 0.64 meters per second square respectively. Ensuring accuracy were one of the factors in our experiment to minimize human and systematic errors, as it can influence the validity of the experiment. To ensure that the experiment was accurate, we used appropriate equipment such as a 1 meter ruler to adjust the height of the half pipe. We use appropriate equipment as it decreases discrepancies that can affect our results if the height was slightly higher or lower than originally planned.
During the experiment trials, there were some factors that may have affected the experiment's validity, accuracy, and reliability. As the ball rolled down the ramp, the pipe was unstable as we used a half pipe, and so it rocked side to side slightly. Therefore, it may have affected the path taken by the golf ball, as it was not traveling in a straight line, which would have affected the time and hence affect all motions.
the height due to human error. The way the height was measured may have some faults, as the retort stand was placed on the floor while being measured, and there could have been some difficulties in measuring a consistent and accurate height for each of the trials.
Our displacement also did not reach 1 meter and instead reached 0.5 meters despite controlling the length of the ramp as 1 meter. This may also be due to human error in measuring the pipe and the rocking of the ball, which led to calculation error. In conclusion, as the height of the half pipe increases, the speed, velocity, displacement, distance, and acceleration increases.